All right. This is 2.6. All right. So this is implicit differentiation. So what we are used to are explicit equations, meaning it's one variable in terms of the other. So what we're always used to is y equals x, y equals some function, y equals, y equals, right? So with implicit differentiation, we don't have to have the equation in the form of y equals. We do not have to have an explicit equation. We can take the derivative of an implicit equation without having to rearrange the equation in terms of y, or to solve for y in terms of x. So an implicit equation is a function by relation between x and y, such as x squared plus y squared equals 25, or x squared plus y squared equals 6xy. So implicit says, hey, there's no need to rearrange and solve for y. Just take the derivative as is. So implicit actually makes our life a lot easier. Okay, so in order to use implicit differentiation, we take the derivative of both sides with respect to x. So we will take the derivative on both sides with respect to x. So we will apply d over dx to both sides of the equation. Okay, so when we do this, there is a little key or legend I want us to follow. It just makes the notation easier and less to write. So I have it down here. Well, first, the relationship, I say we can say d over dx, or we can say y prime. I'm just going to leave it as y prime. Y prime is just easier to write, and it doesn't look as bulky as dy over dx, because some of these problems are going to get pretty in-depth. So it's better just to have y prime. Okay, so I have it written down here, but I'll make another table for it. The derivative of y with respect to x is y prime. The derivative of y squared with respect to x is 2y prime. And the derivative of y cubed with respect to x is 3y squared y prime. And so on and so on and so on. So let me make that little table over here. So if we say d over dx of y, then this means dy over dx, or it also means y prime. And I'm just going to stay with y prime, because like I said, it's the easier notation to use, and it looks easier on the eyes. Use dy over dx if you want. And then to keep going, if I have d over dx of y squared, pause one moment. Okay, back to it. The derivative of y squared with respect to x will be 2y dy over dx, or 2y y prime. The derivative of y cubed with respect to x will be 3y squared dy over dx, or 3y squared y prime. And then, for any powers higher than 3, you'd have d over dx of y to the nth, or any negative powers at that, would give you n times y to the n minus 1, dy dx, or ny n minus 1 y prime. And like I said, I'll stick with the prime notation. If you want to use dy over dx, be my guest. It's up to you. They mean the exact same thing. Okay, so let's try it out. Okay, so we're going to do implicit differentiation. So this means I'm going to apply, not that, d over dx to both sides of this equation. Okay, and then take the derivative of everything with respect to x. And d over dx of 5x cubed, that just says take the derivative of 5x cubed. So that will be 15x squared minus, and now, based on our key, the derivative of y with respect to x is going to be y prime or dy over dx, whichever you prefer. Okay, and then the derivative of -1 is 0, and the derivative of 0 on the right side is still 0. So now, all we have to do is solve for y prime, which means add y prime to the right side, and it's done. So, (15x squared) equals y prime, and done. So, with implicit differentiation, it says, do not rearrange the original equation and solve for y, and then take the derivative. It just says, take the derivative and solve for y prime. But if you can solve for y, that is another way to check your work. Let's check it out. Let's say I wanted to solve this one for y. Then I would move the 1 over, and I would move the 5x cubed over. You would get y equals negative y equals negative 5x cubed plus 1. Then take the derivative, well, don't take the derivative, divide by -1, and you get y equals 5x cubed minus 1. Now take the derivative, and you would have y prime equal to 15x squared. All right. But the point being is, we get the answer either way. But again, the point of implicit is, you don't have to rearrange and solve for y. And when we get to harder problems, you won't be able to rearrange and solve for y. So that's why implicit was created, to make our derivatives easier. Okay, do it again. Y squared plus x cubed plus 4. Again, don't solve for y, just take the derivative with respect to x. D over dx applied to both sides. Now, let's take the derivative of y squared with respect to x. Follow that little key I made. The derivative of y squared is going to be 2y dy over dx, or 2y y prime. Like I said, I'm going to stick with primes. So here we go. You will get 2y y prime plus 3x squared. The derivative of 4 is 0. And on the right side, the derivative of 0 is still 0. Now solve for y prime. Subtract 3x squared to the right. Divide by 2y. And we get negative 3x squared over 2y is equal to y prime. That's it. And now, let's say that we wanted to solve for y on this one. I'm just going to show you. I'm going to show you why implicit makes our life easier. So let's solve for y on this one. Move x cubed over and move 4 over. And now, to get y by itself, square root both sides. I know we'd get a plus or minus, but we'll ignore that for now. Now, take the derivative. But before we take the derivative, we have to rewrite the square root. And now take the derivative using chain rule. And doing this work should already be a red flag because this work definitely seems a lot harder than that work. But you'll see, we're going to get the same answer. It's going to blow your mind. Now, if I put it together, I'll have, oops, let's use the derivative. There we go. I'll have y prime equal to negative 3x squared. So I'm leaving that in the numerator. The 2 is going to the denominator. And so is negative x cubed minus 4 to the negative 1/2. Okay. One more final rewrite, and y prime and there we go. We get the same exact answer. Well, now, does it look the same exact answer? The answer is no. But you can find some similarities here. One, both numerators are negative 3x squared. We have a 2 in both denominators. But do I have the same y value down below? And that answer is yes. Do you see it? Right here. Y is the square root of negative x cubed minus 4. So the square root of negative x cubed minus 4 becomes y. And now, do we have the same answer? And that is a yes. Crazy, right? So now you see why implicit makes our life easier, because we didn't have to go through that chain rule. We just didn't have to rearrange. We just took the derivative as is and solved for y prime. But you see, either way, you'll get the same answer. But that's only if you are able to solve for y on the original equation. Some equations, you won't be able to solve for y. So you just do the implicit and don't worry about any of that. I mean, we don't have to worry about anything I did on the right. I just wanted to prove to you that I could get the same answer using two different methods. Okay. Cool. All right. 3. This one, you definitely can't solve for y. There's no possible way to do it. So we're doing implicit. We don't care about solving for y. We only care about solving for y prime. So take the implicit derivative with respect to x on both sides, like we did on the last two. I won't prove anything else anymore. Let's now just practice doing implicit derivatives. Do we have to apply d over dx to both sides every single time? Yes. Okay. Now, reference the legend or the key I made on the first page. The derivative, the implicit derivative of y squared with respect to x is 2y, y prime, minus the implicit derivative of y with respect to x is y prime, minus the derivative of 4x, which is 4, equal to 0. Okay, now in this step, remember we always solve for y prime. So isolate your primes together. This means take 4, move it to the right side. Okay, and then remember again, you're solving for y prime. So your greatest common factor is y prime. Factor it out. You see, once again, purely algebraic. Factor the y prime out, and you're left with 2y minus 1 equal to 4. And now all you have to do is divide by 2y minus 1. And you'll get y prime equals 4 over 2y minus 1. Done. Whew. You can attempt to solve for y up here, but you're not going to get it anywhere. Okay. Keep going. All right, 4, same exact thing. All right. And now take the derivative with respect to x. And on the first one, we're going to have to take a quick breather and realize what we're doing. So now when it's in implicit form, the term is represented both by x and y, by two functions. X and y are two functions. So since I have an x times a y, we're going to have to use product rule on this derivative, on this part of the derivative. Function x times function y is going to use a implicit product rule. What? I know, right? So what I like to do is I leave the 3 out of it. So what I'm going to do is put brackets around the xy. We'll distribute the 3 later and say we are doing product rule implicitly. Or put that in front. An implicit product rule. Okay. So let's label what we have. And F will be X. G will be Y. The derivative of X is 1. The implicit derivative of Y, we must remember this is still implicit. The implicit derivative of Y, Y prime. Implicit, right? Okay. Okay, well, let's put it together. Don't forget the 3 on the outside. So we'll have 3 parentheses. Follow your product rule. F prime G, we get Y plus G prime F, Y prime X, or to be alphabetically correct, XY prime. Close parentheses. That is the derivative of the very first term. My goodness, right? Now let's look at the other ones. I have the derivative of negative 2x, which is negative 2. And everything else will be 0, right? Negative 2x is 2, negative 2 is 0, derivative of 0 is still 0. Okay, now remember what we're solving for. We are solving for Y prime. So what I'm going to do here is add the 2 over and distribute the 3. Three y plus 3xy prime equal to 2. And then, remember, we're solving for y prime, so move 3y over to the right. And then, to get y prime all by its lonesome, you will divide by 3x. Which means we'll get y prime equals 2 minus 3y all over 3x. Now, it is very easy to make a mistake. Very, very easy. So watch all your signs, watch everything. Do not forget any steps. Okay, and then to save you some time, since I have so much room over here, remember this implicit derivative for x times y. It'll save you time on your homework. So we can say implicit derivative of xy is, what is it? Y plus xy prime. save that for later. That'll save you time. So you're like, oh, I know what that is. Boom, put it down. So we don't have to go through product rule, product rule, product rule. Okay. All right. Again. D over dx of x cubed y equal to d over dx of 0. Okay, well, this is just like the last one. Take a quick second and realize that what do we need again? We're going to need product rule again. Implicit product rule, IPR, right? Where f will be x cubed and g will be y. Okay. F prime, 3x squared. G prime, implicit y prime. Okay, the worst is over. Now, don't forget the 2 out in front. Parentheses, f prime g, 3x squared y, plus g prime f. I'll put it as x cubed y prime. Okay, bring in the other players. Derivative of negative x cubed, negative 3x squared, and everything else will go to 0, right? Negative 3x squared. Okay, we're here. Now we must remember, solve for y prime. Solve for y prime. Distribute the 2. Add the 3x squared over. Remember, you're still solving for y prime. So move 6x squared y over. And then, to get y prime all by its lonesome, divide by 2x cubed. Okay. Is there a chance to clean up here? There definitely is. Is there a common factor in the numerator? That answer is yes. You can take out a 3, and you can take out an x squared. Let's try it. And if I take out a 3x squared, that leaves me with 1 minus 2y over 2x cubed. And then we see that my x squared and my cube will cancel, leaving me with the final answer of 3 times 1 minus 2y over 2x. And done. Good stuff, right? Okay. Very easy to make a mistake, trust me. And if you want, you can even save that derivative to save you time if you ever see x cubed y again. All right, so up to you. I won't make it fancy this time. All right, 6. Oh, is this the last one? Wow, yep, that is implicit. Okay, so number 6 is important. So you have sine of x plus y equal to y squared cosine x. Well, this problem is going to use chain rule on the left side and product rule on the right side. Also while being implicit. Oh, what? Right? So we're going to have a chain product implicit derivative here. So again, like normal, d over dx of the sine of x plus y equal to d over dx of y squared cosine x. Okay, let's go ahead and take care of the left side. So this will be chain rule, right? The outside function is sine. So using chain rule, the derivative of sine is cosine. So we'll get cosine, and remember, chain rule is derivative of outside times the derivative of the inside. So sine x plus y is the whole outside as well. So you're going to get cosine of x plus y times, so that's the derivative of the outside, times the derivative of the inside, the implicit derivative of the inside. So the derivative of x is 1, and the derivative of y, the implicit derivative of y prime. That takes care of the left side for now. Now, over here, product rule, implicit product rule. So f will be y squared. G would be the cosine of x. The implicit derivative of y squared two y prime, the derivative of cosine, negative sine x. Okay, we're ready. Follow your product rule, and we can complete the right side. F prime g, 2y, y prime, cosine x. G prime, negative sine x times y squared. I'm going to rewrite that as negative y squared sine of x. So it would be plus, but since it's negative, we'll just put a minus there. Okay. Let's look at what we have. Cosine x plus y times 1 plus y prime equal to 2y prime cosine x minus y squared sine x. Now that just looks like one big mess, right? So remember, when you get to this part, remember, you're solving for y prime. So you have to put your y primes together, which makes us look at the left side. How do I get this y prime out of the parentheses? Well, in order to do that, you're going to have to distribute, yes, distribute. Maybe I should use different colors here, right? Chain rule. Just go to the bottom here. You're going to have to take cosine x plus y and distribute it to the 1 and distribute it to the y prime. The whole thing. It would be wrong to think that the y, you FOIL these parentheses. That is incorrect because x plus y belong to cosine. That is the argument that belongs to cosine. And remember, nothing can distribute inside there. Okay, so if we distribute this, cosine x plus y times 1 is cosine x plus y plus cosine x plus y times y prime is y prime cosine x plus y. All right, the left side's done. We distributed it. We distributed it. Yeah, sure. Distributed. Whatever. You get it. Equal to 2y prime cosine x minus y squared sine of x. Okay, so after distributing, we do what we know. Put your y primes together. So I am going to take 2y prime cosine x, subtract it to the left. And I'm going to take cosine x plus y, subtract it to the right. So after I do that move, I should have y prime cosine x plus y minus 2 y prime cosine x equal to negative y squared sine x minus cosine x plus y. Woo! And now, after that, it's a lot to look at, trust me, I know. There's so many letters, I just don't even want to look at this screen anymore, okay? All right, after that, remember what we're still solving for, y prime. So, factor out the y prime on the left side. And we'll We're almost home. The right side stays the same. And then divide by all that nasty stuff on the left. Divide that off. Oof, it's ugly, right? Divide. Okay. Our final answer is y prime equals negative y squared sine of x minus cosine x plus y all over this nasty looking denominator. And there's nothing else we can do. There's nothing else we would want to do. Done. So take it slow. Know what rules you're going to use. Is it a chain rule? Is it a product rule? Is it a product or quotient within a chain? Just know how to use all the rules together. And that is implicit derivatives. That's it. Nothing else to it. Use dy over dx if you like, or y prime. But done.